Alright, 4-7 is about congruence and overlapping triangles. As you can see from the picture, the triangles are on top of each other with one, maybe two, maybe three overlapping parts. But remember, the common part has to be completely overlapping. So if you see CD here, it's not overlapping a whole part of triangle EBC, so you can't really say anything. See that line right there? It's only overlapping half of CE, so really can't talk about that. So when we're talking about identifying common parts, it wants to know what common angle do triangle ACD. Let me go ahead and do that. ACD, I'll do it in red. And then let's do it in blue. ECB is the other triangle. What do they share? Well, what completely overlaps it? And if you take a look at where the blue and the red completely overlap, that's going to be at angle C. Angle D it kind of does, but angle D is just the red part right here doesn't overlap with the blue part. But if we look at angle C here, the red and the blue overlap the whole way. So the angle they share would be angle C. Problem 2 says using common parts. So again, you're proving this, so let's make our statement reason chart. And again, this is going to be a little cramped, so I might go to the next page. But if I separate these two triangles, so this would be triangle ZWX, and this would be triangle YWX. Okay, it sometimes helps to put this proof into perspective. And what it gives me is it says angle ZXW is congruent, ZXW is right here, is congruent to YWX, which is right here. Then it tells me ZWX, which is right here, is congruent to YXW. That's YWX, that's YXW. Okay, so we have our two angles congruent. But if I look at my proof here, and then let's take my statements. One, angles congruent, I'm not going to rewrite it because I'm kind of cramped for space, is given. And two, angle ZWX is congruent to angle YWX. Again, that's given as well. So we're stating our given. And this kind of falls around along with our proofs that we've been doing. If we have WX here, notice how it's the side there, and WX is also the side. Well, if we look at our big picture, you can see WX is congruent to WX. And of course, that would be reflexive. You guys are getting real good at recognizing that. Okay, so that's reflexive. So now we have our three parts, angle, side, angle. I can state triangle ZWX is congruent to triangle YXW by angle, side, angle now. Okay, and number 5 here, I'm going to just move it over to the right here. Number 5, we're going to state ZW is congruent to YX by everyone's favorite CPCTC. Can't fit it in there, but you understand the concept. Problem 4 is talking about separating overlapping triangles. This is a doozy of a proof, I will tell you that much. So we'll work through as best we can here. It's going to be hard to explain. We'll probably have to go over this one in class as well. But let's start with our given like we always do. 1, BA is congruent to DE. And 2, CA is congruent to CE. It's given. And that's given. Okay? So what does that really tell us? Well, what that tells us here is that we have CA congruent to C. So the big triangle, triangle CAE, is an isosceles triangle. So again, that kind of tells us that if we look at the two small triangles, BAE, so let me draw them over here to the right. It's triangle BAE. We know that BA, and then let's look at triangle DAE. we know that BA is congruent to DE, which is right here. And because that we know that that big triangle is isosceles, we could say that our base angles are congruent, which is right there. So I could say 3, angle CAE is congruent to angle CEA because base angles of isosceles triangles are congruent. What does that give me? Well, that gives me this angle congruent to this angle. Okay? So we have those angles, and we need another piece there. Again, I'm out of givens, so what do? We call a best friend. See how this is AE and this is also AE? We can say AE is congruent to AE by reflexive property. Okay? Once I have that, I can now state that triangle BAE is congruent to triangle DEA by, well, we have two sides of an angle. If I look at it, there's that side, 5 is side angle side. Well, how does that help me? Well, again, remember what I'm trying to prove. I'm trying to prove BX is congruent to DX. Well, BX is here. Let me use a different color. BX is here and DX is here. What triangles are those parts of? Okay, those triangles are those sides are part of triangle BAX, and if we look at it like this, let's go to the next page. It's going to be triangle BAX and triangle DXE. Now, if we go back and look at the triangles we proved congruent, since I have these triangles congruent, I can say that angle BAE, which is right here, ABE. Well, ABE is congruent to angle EDA, which is right here. So if we go to the next thing, by CPCTC. So if we go next thing, that's this angle is congruent to this angle right here. Remember, we already have this side and this side congruent from given. Okay? Okay, so we can start here where this would be number 6 now. Again, this could be a little rough, I apologize. 6, we're going to say angle ABE is congruent to angle EDA by CPCTC. Okay? We're kind of out of givens. We're out of CPCTC. We've already used it. There's nothing else that can help me here. Well, what do I have here? Well, again, I can call my other best friend. These right here look like vertical angles. I know my drawing's horrible, but angle BXA is congruent to angle DXE by vertical angles. Vertical angles are congruent. Then I can go ahead and say 8 triangle BXA is congruent to triangle DXE by angle side. Once I state my triangle is congruent, I told you this one's crazy. I can now say BX is congruent to DX by CPCTC. Again, corresponding parts of congruent triangles are congruent. Crazy proof. Probably the hardest proof that you guys are going to do is something like this. It's overlapping triangles. It's crazy proofs. But we'll get through it. We'll be alright.